Let's discuss about the optimal merge pattern, which is again a greedy application. So here what we have to do is we have to merge the different files of the different length into a single sorted file. So that is the objective of optimal merge pattern. And in that, what is the constraint is we need to find an optimal solution where the resultant file will be generated in minimum amount of time. Here that is minimum amount of time is minimum number of record movements that we will discuss in the example. Now, if the number of sorted files, the sorted files, why it has come, that we will see with one example, and then we will, for the time being, this is a sorted files are given. There are many ways to merge them into a single sorted file. Means, suppose if I have file 1, file 2, and then file 3. So I can merge the file 1 with file 2 and then file 3. This is one pattern, or otherwise file 1 and then file 3 and then file 2. This is the another pattern. And then again I can go with file 2 with file 3 and then file 1. So in this way I have different ways to merge them into a single sorted file. And here one constraint is there. This merge can be performed pairwise, means at the same time you can merge only two files. So hence this type of merging is called as a two-way merge patterns, or otherwise we also called as the binary merge patterns. So at the same time, you can merge only two files. This is the two-way merge patterns. Let's discuss one scenario. We have four different files. These are the different length of the files, or you can call it as different records which are having in the files. So file one consists of 7 records, file 2, 4, and so on. So now let's discuss. Let me merge this. I told you that there are many different ways of merging these files at the same time, that we need to find out which one is the optimal one, optimal merge pattern. Suppose 7 and 4, I am merging it out. This will give me 11. And then if I am, let us say that this, and then I'm merging it with the 3. So this will give 11 plus 3, that is, it will give me the 14. And then this 14 and then 2, this will give me 16. Yes, total number of records are 16. So what are the, how many number of records that we have merged in each and every phase? So this will give you 11 plus 14 plus 16. So now let's see the another scenario. So here I'm having the same files in different way of merging. Now let me merge file 1 and then file 2, which will give me 11. And then I'll merge file 3 and then file 4, which will give me 5. And then next again I'm merging it out 16. So this merge pattern gives me like 11 plus 5 plus 16. Next, one more scenario that we will see. Here, what I am doing is, first let me take the minimum values, minimum records. So this is 5, and then next minimum is 4. So this and then this. So which will give me 16, sorry, 5 plus 4, this is 9. And then next is 9 plus 7, which will give me 16. So here I have 16 plus 9 plus 5. So if I add up over here this merge pattern, so what is the cost? So here this is 25, 31, and then 41, which will give me the 41. And next is 11, 16, 16 plus 16, 32. And then here 24, 24, and then 5. Sorry, here 9 plus 5, 14, 14, 20, and then 30. So this will give me. So which one is best? 41, 32, and then 30. Out of this three, this is best. So here what I have done is exactly I have taken the minimum records and then I have merged. So this is the one which I have discussed with you all earlier. There are many ways to merge them into a single sorted file. But what is required is we have to get the resultant file within the minimum record movements that we say over here. Now, here the different pairings require different amounts of time. That's what we have seen in the last scenario, 41, 30, and then 32. So these are the different timings. In this strategy, we want to determine an optimal way of merging many files together. At each step, two shortest sequences are merged. So from that, we have summarized two shortest files will be taken and then it will be merged together, and then the next shortest. In that way, we will be merging all the files. To merge a file, suppose if one first file one is having M record and then the second file is having N records, so possibly how many moves that how many I so possibly how many records that I am moving together is M plus N records. So then the smallest files together, like each and every phase, that we will be seeing to the next shortest files that we are going to merge. So here, let's take the one problem. Four files are there and these are the records. So the question is, given a set of files from F1 to F4 with the following number of pages or records, find the minimum number of record movements to merge into a single file. So let's start with the problem. So the procedure is like, first what we have to do is sort the files as per records. Here it is given in the non-sorted order. So we have to sort the files as per the records and then merge the file using heap operations. So here you can take the minimum heap and then you can take the smallest value, right? So you can use the minimum heap operations. Next is find out the total number of record movements. So these are the three steps that which we are going to follow in this optimal. So here is the example that let us first step is sort as per the sort the file as per the records. So first one is like what? F3 is taken and the next highest is F2. You can recollect the Huffman procedure also, the way that we construct the Huffman tree. So the F3 is having 2 records and then F2 is having 6 records. So together it is, the summation is 8. Now next is, the next minimum is 8. So again I am taking F4, so which is having 8. So which will give 16. 16 again you have to put back into the sorted list. That is the heap operations that we are performing. Each and every time after merging, then again we will put it in the sorted list. Again after 16, then again we will put it in the sorted list. Next is the F1. F1 will be having, F1 is having 10 records and then combined together, we will be getting 26. So anyhow, 8 plus 8, 16, and then 10, 26. Total 26 records are there. So now, what are the record movements? So here you can say that 26 plus 16 plus 8, 24, 30, and then 50. That is the one. And next is number of record movements. That is also the same. So number of record movements is like, suppose if I am taking this F3, F3 that I have stored here, and again when I am merging with the F4, again I am moving this records from this location to this location. So when I am moving from one location to another location, there is some cost will be there. Some time is taken while moving the records from one location to another location. So if you see this one, this F3, when it is moved, that is 2 into 3, 3 times. What is this one? 3 from where I have got? This is the distance. 1, 2, and then 3. 3 locations I have changed. That is the distance. So F3 is number of records, that is 2. And then 2 into 3. 3 times it is moved. And next one, F2. F2 coming to this one, number of records are 6. And how many times it is moved or the distance? If you see 1, 2, and then 3. So this is also 6 into 3. And then next is F4. F4, how many times it is moved? This is one time. And then what is the distance? So 8 into 2. And then next is F1 that is moved only for once. So sorry, F1 is 10, 10 into 1. So you can see from this one, the largest number of records, the files which is have consisting of more number of records are placed at the last to reduce the number of record movements. So this will give you 6 and then 18 plus 16 plus 10. So 26, 34, 44 and then 50. So number of record movements are 50 and this is your optimal merge pattern. So let's see the algorithm. So here we are constructing a tree with the number of nodes n. Here 1 to n minus 1 files that we have to see, and then we will be declaring a node. So we have taken that first is F3 node and then F4 node. So in that way that we are declaring a new node. So nodes left child is least of all the list. So if you see in the previous example, what was the thing? It was like 2, 6, and then 8, and then 10. So the minimum is 10. Sorry, minimum is 2 and the next minimum is 6. So this 2 are taken and then created as the list. So this will be your left child and then this will be your right child from the list. So node right child is least of list. Next least value from the list. And node weight equal to node of left child weight and then node of right child's weight. So 2 plus 6, that is 8. That is your new node. That is the weight of the new node. Next is insert list of node. Again, what we will be doing? Again, we will be putting back into the heap tree. Next is return the list and then the list of nodes which we are having. So this is the algorithm of optimal merge pattern. Here one more example is given for you. You can try this out with the pattern of 11 files and the length is given. What are the total number of record movements and what is the optimal merge pattern? That's it for today's lecture.